So it's about to start. Okay, now it's recording. So welcome to today's tutorial. We'll be going through a past paper, the 2022 past paper. I think so. But it's actually the 2018 past paper. You know that they repeat past papers. So what I'm going to do is I think this should be pretty straightforward, but it's fine. We'll do it, but I'll do it as like the last question. I'm just gonna skip that for now. So I'm going to start from question 2. So I'm going to open Microsoft Word. I'll just use Microsoft Word to write the answers, and then when I'm done writing the answers, I'll save it as a PDF. So there we go. And then I'm going to choose Arial font, and then I'm going to make it 14 or 16. Let's use 16. And then this will be question 2. So I'm gonna close one of this and then delete. And then, okay. So answer in the provided answer book, right? You guys will be given the answer book. So that's where you'll be writing answers. Which one of the following Windows command line instructions list the files in the current directory? So in terms of things like terminal stuff, like the command line, right, or the terminal or the console, there's different commands that you can run to do certain things. So, for example, when I click on File Explorer here at the bottom, I click to open my folder, right? You can do that via CMD. You don't have to use the graphic, right? So this other console terminal that I downloaded. It's a bit different, but it works. But it's a bit modern. So this is the one that I use. So I'm gonna type clear. So there's different commands, right, that you can run on the command line. So for example, if I wanted to, let's say I wanted to, what is this? Let's say I wanted to look at where I currently am, right? Like where I am. I'm gonna type the command pwd, which stands for print work directory. So print working directory. Another word for directory is folder. It's like a fancy word. It's a fancy word or a fancy way to say this is a folder. We call that a directory. So pwd, right, just stands for print working directory. So basically print the current folder that I'm in. So I'm going to go back here and then run the command. You see that it shows that I'm currently within this folder. Yeah, this is a very nice IDE. I'm not going to lie. You see that I can actually click open to open the folder, and then boom, it opens it. Yeah, you guys should get this terminal. So to get it, you're gonna go to, it's called I think it's called WAP. So WAP.dev, if I'm not mistaken. Yeah. So it's called WAP. This is the terminal. You just click download here and then boom, you install. So this is a nice editor, a nice console, I mean, or a terminal. So there's different commands that you can run on the terminal. Let's say you want to list what's currently within the folder. So I know where I currently am. So I'm basically in the Tether folder, right? So to look at what's inside the Tether folder on Windows, there's different commands for specific operating systems. So if I was using a Linux or Unix-based operating system like a MacBook or Mac OS, I mean, you're gonna type ls. That stands for list, to list everything. But since I'm on Windows, we use dir, which is short for directory. So in short, it basically means print what's currently in this directory that I'm in. Then you're gonna say dir and then you press enter. And then boom. You see that it lists everything that's currently inside of my folder. So there's the word, it tells you which directory. There's the directory, and then this is everything in the directory. And then you can, let me see, Yeah, I'm not going to explain too much on this side here. You see this side here, this column. I won't explain too much because it's mainly shown on, what is this, Linux or Mac OS. So I'm not going to touch on this, but you can see this is the date, this is the time those folders were created. And like I said, this terminal is cool. It's like the latest cool thing. You can click here to open the folder, and then it goes to that folder. So you see, this is everything currently within this directory. Then now I can type different commands to move in or to delete a file, to create a file. I can do all of that. But that's not what we're trying to find out. We're trying to answer this question. Which one of the following Windows command line instructions list the files in the current directory? The main key thing to understand here, they said Windows. On Windows, you use dir. So this is the answer, dir. You don't use all the other commands. So that would be the answer. The answer would be B. So for A, I'm gonna say the answer is B. And then we go back to the question paper. So which one of the following C++ data types cannot store, the main word is cannot store a value greater than 127? So which variable cannot store a value that's greater than 127? String is out of the picture because string, it can store any number as long as it's placed within the double quotes. So even if it's 2 trillion, I can put it within double quotes and make it a string from that. So this means string can accommodate actually any length. It's to infinite, any number. So this is out of the picture. Float, it supports a very big or wide range. So it's out of the picture. Also, this double, it supports double of this. So obviously it is big. And then integer, it is very big. It supports a very big limit. So let me explain a bit of give you a bit of an explanation of the ranges for each data type. So how do you find the range? What is the formula to find the range for each data type? So the formula is base 2. Why are we using base 2? Because base 2 is used because a computer uses the binary number system. By binary, we mean by which means 2. And what are those two values? It's 0 and 1. Where 0 would represent a false state, and 1 would represent a true state. By true or false, I just mean electricity. Remember, your computer uses electricity. So the language that the computer speaks, it's zeros and ones, meaning 0. When you have 0, it means that there's no presence of electricity, or there's little presence of electricity. When it's a 1, it means that there is a presence of electricity. So that's basically why they chose to use 0 and 1 as the language of the computer, because a computer, it needs electricity in order for it to exist, right? For example, I'm teaching you right now, and you see, if you look down here, my laptop is currently charging, because the laptops, that's how they rejuvenate. That's how they get back their energy, by you charging them. As human beings, we go to sleep, so it's a different case for us. That's how we recharge. To recharge a laptop, you have to actually charge it, put in current or electricity. So you can think of these zeros and ones like a switch in your room. When the switch is off or when the lights are off, we'll say that's a false state, meaning there's no presence of electricity, which is like load shedding. And then when there's a 1, when you switch on or you press the switch to switch on the lights, then it's going to be true, meaning true, there is a presence of electricity. So therefore, it uses zeros and ones to represent information. That's how information is stored in a computer. It uses zeros and ones. That's why we use base 2 as the number system, as the base for this number system, because we only have 2 digits in this number system. If you go back to our number system, which is the decimal number system, right? Our decimal number system, it uses DEC, right? It's the DEC system. DEC just means 10, right? And that's true because the decimal number system actually uses 10 values to represent any number. So for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you count these numbers, these are 10 numbers. So that's why we use base 10, or this we call this base 10 or DEC for short, right? So you might ask yourself, well, I've never seen them, but I've never written base 2 when I'm writing numbers. How come, or base 10? I mean, how come you are telling me that this is base 10? When did I see that? So let me make an example. 123, how would you represent that? 123 is basically the same as 100 plus 20 plus 3. We all agree, right? But how can you represent 10 in terms of base 10? We want to use base 10 because there's 10 numbers in that number system. So this will be 10 squared, right? So this will be 10 squared times 1, right? Because it's not 200. If it was 200, then we're going to say times 2. If it was 300, then we're going to say times 4 or 3, or if it's 400 times 4, if it's 500 times 5. In this case, it's just 100, so I just say times 1. Plus, so I'm going to put brackets here to distinguish the operations, plus 10 to the power of 1 times 2 gives us 20, plus 3 times, or let me just start with 10, plus 10 to the power of 0. Because remember the rule in maths, any number that's to the power of 0 is a 1, times 3. So this basically means 1 times 3. So as you can see, I've represented this number in terms of base 10. Why is base 10? Because there's 10 numbers in that number system. So that means if you see any number like this, just know under the hood, this is actually the way they found those answers. So I'm breaking it down so that you actually see what's going on. So just like we did this, even in binary, if you have, for example, a number, let's say, for example, I don't know, let's say you have, I don't know, let's say you have a number in binary. That number that you want to represent, you'd also use that base for that number system. So base 2 in our case, for example, base 2 to the power of 1 times something, blah, 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 and so on. So you'd use base 2 in that number system because there's 2 numbers in that number system. I hope this is clear. So with that being said, since the computer uses base 2, we can use base 2 to find the range of each data type, because under the hood, each data type is its length, even its length is stored as bits, or we also call them bits, right? So there are another word for 0 and 1 is called binary digits. So 0 and 1, these are called binary digits. Bi meaning 2. So basically they mean these are 2 digits in simple words. The shortcut for this word, for this big word, binary digits, it can be abbreviated as bits. And how did they find that word? It's simply, you just simply remove this. You delete those words in between, and then you're left with bits, which just stands for binary digits, which just means 0 and 1. So how can we find how many bits are used to represent a number, right? It's simple. There's a rule. The electrical engineers, right, who came up with the hardware, we made the hardware for the computer. They have a rule or a formula that they used, and they told us what the formula is. You don't have to understand how they've got to that conclusion and understand the hardware and stuff. That you can go and do your own research. So the formula is you look at the base, you use the base, right, to the power of bits minus 1. So this is how you'd find the range using those bits. So you start from this, so minus, and then you subtract. So remember, to find a range, each variable, remember each data type, also needs to accommodate negative numbers and positive numbers. So when you specify the range, we're going to start from a negative range to a positive range. That's how it works. So I'm going to say minus base to the power. This represents to the power of what? Of bits minus 1. 2 positive base to the power of bits minus 1. And then that final answer, you're going to subtract a 1. So this 1, if you look at the textbook and you find out why they subtract that 1, because our range includes 0. So we need to subtract that 0. We don't want to include 0 in our range. So that's why we put that extra minus 1. And it's only put on the upper range, meaning on the positive side, right? So this will be the formula. So minus base to the power of how many bits, meaning how many binary digits, basically how many zeros and ones, to positive base, whatever that base is, up to the power of bits minus 1. Then that final result, that final answer, you subtract a 1 because it's going to include 0. We don't want to include 0 in our range. So I hope that makes sense. Yeah, just one thing at a time, guys. Patience, will get to the answer. So how do we know how many bits are used to represent each data type? They told us, the electrical engineers, right? Those are engineers who make the parts for the computer. They told us what is the range for each data type. So the range, if I'm starting from char, right? So let me use char. So char, it's 8 bits, meaning 8 binary digits, meaning it's a combination of zeros and ones, of which it's 8 of them. So 2, 4, 6, 8. So 8 bits. Those are the number of bits that are used to represent a char. Then we have and another thing that you need to understand, this formula, 8 bits is equivalent to 1 byte. We can say that's 1 byte. So this will be 8 bits. So if it's 8 bits, this will be 1 byte. And then we have the data type short, which is 16 bits, which is 2 times, right? Look at this. It's 2 times this. How did we move from 8 to 16? We multiplied 8 by 2. This is simple math. So if I multiply 8 by 2 here, so it's obvious that if this is 1 byte, 1 times 2 is 2. So this will be 2 bytes. And then we go to int, which is 32 bits. So the way it works, right, you always multiply by 2 to get the next range, especially if you're placing them in order. As you can see, I started at 8, I multiplied by 2, then it became 16. 16 times 2 is 32, and so forth. So this will be now 4 bytes. Why 4? Because the previous one was 2. 2 times 2 is 4. So this will be 4 bytes. And then we have long, right? So I'm going to have long, which is 64 bits. Remember, we're timesing by 2, which is 8 bytes. And then we have the floats and the double. So this will be a 32 bits IEEE 754, right? And then this will be double 64 bits IEEE 754. So you might ask yourself, what is this IEEE? If I still remember well, it's the Institute for Electrical Engineers and something. I forgot the last E. But you can Google it on Chrome or your favorite browser and check what that means. Basically, this talks about the was the Institute of, I think it's the Institute of Electrical and Electronics Engineers, something like that. So this basically it's referencing the people or the organization that was responsible for coming up with the ranges for these 2 types. It's those engineers. So we're just going to take their word for it. When they tell us float is 32 bits, we need to trust them because they're the ones who made the parts. So this is the ranges. These are all the ranges. But we don't really need the bytes part. You see the bytes, we don't need the bytes. We need the bits because we're trying to find the range. Because if we check the formula, we're using the bits. So to find the range for a char, it's 8 bits, right? So that means it's minus base. What is my base? Let me do it this way. What is my base? It's base 2 because it's the binary number system. Base 2 to the power of how many bits? 32. No, what am I saying? 7, 8. And then minus 1, it becomes 7. So this is 8 minus 1, which becomes 7. So minus 2 to the power of 7 to positive 2 to the power of 7 because 8 minus 1 is just 7. And then you subtract 1 in this value. If you put in your calculator right now, calculate, you'll find out that this will be the answer minus 128 to positive 127. So why do we use this formula of specifying a base up to the power of bits? We're using that formula so that we find the right integer in our number system. Because if we leave it in terms of bits, we won't know what actually, when we need to translate it into our language. Remember, we use the decimal number system. We don't use binary. So it needs to be put inside, represented in a number that people can understand, which is this number. You know what minus 128 means, right? It means minus 128. So that means, in other words, this translates to, for those mathematicians out there, this translates to inclusive minus 128 up to positive 127. That means it's between this exact range. So if you put a value that's smaller than this, you're out of range. If you put a value that's greater than this, you're out of range. Then you can also check for data types like short, put 16, put this, put that, and check for all of that. But that doesn't matter in this case because we found a data type that doesn't store a value more than 127. It's a char. Because if we calculate for a short, it stores around 32,768. Yeah, so it's if you use the same formula for, let me write down. So for a short, if you use the same formula, it stores from minus 32,768 up to positive 32,767. That's the range. And then for an int, it's somewhere between minus 2 billion to positive 2 billion. So for the maximum, you see that the numbers keep on increasing. For a long, its maximum is 9 quintillion. That's a very big number. Its minimum is minus 9 quintillion. So that means we are going a bit too far. We already have found the range of the data type that cannot accommodate a value bigger than 127. It's a char or a character. So if I go back to my code, to my question paper, I mean, which one of the following C++ data types cannot store a value greater than 127? Now the answer becomes very obvious. This stores a maximum of 2 billion. This stores, I can't calculate it by head, but you can write a formula for that, but it's a very big number. It's probably bigger than an int, right? It is bigger than an int. Also, float is bigger than an int. Like I say, string is just a string. You can put any number in between double quotes, even 9 quintillion. You can put it within double quotes, and then it will still accept it as long as it's between double quotes. So string is not even part of the possible answers here. We can just eliminate it. Then we're left with only char, which is true because if you look at the formula or the range, the maximum a char can store, it's exactly 127. And here they say choose which one that cannot store a value more than 127, which is a char. So it's A. So for B, the answer is going to be A. You might ask yourself, why am I taking so much time to explain? Because they like to repeat questions, and if you just cram the answers, they'll give you a different question paper, but they ask a similar question. Maybe they say which C++ data type cannot store more than 32,767. That your answer has to be short because the short stores a maximum of 32,767. So you see, knowing the answers is very important because they might change it up a bit. So in C, question C, preprocessor directives begin with the symbol at. False. This is 3 marks. What is a preprocessor directive? Preprocessor directives is just instructions sent to the preprocessor to tell it to perform a specific task. So the preprocessor, it's called pre because it's before processing, right? Remember pre means before. So before what? Before processor, before processing. So that means this is called before processing your code. So this guy, his task is to just follow commands. I'm going to put it in that way. He is just meant to follow commands. So how do you command it to do something? You command it by starting with the hash symbol. For example, you tell it hash include, meaning hash, and then that's the instruction. That's you telling the preprocessor, I want you to do something. Then it's going to ask, okay, I'm listening. What do you want me to do? Then you tell it include. Therefore, it's going to go and look for that file and include it into your .cpp file. So let's say you have IO string. So it's going to go and look for this file with this name. You see here, this file over here. It's going to go look for it because you gave it a command to include it. So you see how this is how preprocessors how they begin. They begin with the hash. So the answer for this is false, right? So you just write false. So C is going to be false. And then we go back to our question. Which one of the following expressions represents the character 0 in a char data type? This is very tricky. They said the character 0, right? And they said in a char data type. A char data type is initialized with single quotes. That's something you need to really understand. That's why it's important to do your practicals. A char, you create a char like this. You say char, let me say input or something. And then let me initialize it. Use single quotes. If you want to set a char to nothing, how do you set it to nothing? You put in a backslash and a 0. This translates to null or nothing. This actually translates to null or nothing, meaning there's nothing inside of it, right? It's equivalent to you making an integer, let's say int num, and initializing that integer to 0. It's equivalent. So this is the equivalent of this, but then in a char way, right? Or using the char data type. You put in this. This is null. Don't confuse it. This is not a 0. It's called null. It is a special term or a special name for it. It's called null. Then if we check here, as I finished discussing, a char data type is stored using single quotes. Anything that's not in single quotes, it's out of the picture. This is out of the picture. There's no quotes at all. This is double quotes. This is the string out of the picture. This is a string because there's double quotes out of the picture. So now we're left with this or this. But then remember what I talked about. This means null or nothing. Here they said the character 0. If they said if the question was which one of the following expressions represents the character null in a char data type, then this would be the answer. Here they're not looking for null, they're looking for literally 0. So this would be the answer D, because you see there's D. The only difference between these two things is the backslash. When you use the backslash in conjunction or in combination with 0, that translates to a null in C++. So C++ views that or takes that as a null instead of 0. But if you remove that backslash, it's going to go, oh, you mean 0, which is exactly what the question wants you to do. So this will be D. So the answer will be D. So D. Yeah. No, DD. DD. Yeah. So which one of the following identifiers are illegal in C++? The term is illegal. And another term that you need to understand is identifiers. So identifier, I want you to understand something, right? Learn the skill that I have. I have this ability to look at a word, and if I see that I don't understand it, I try to break it down. So for example, identifier, it comes from from the root word identify. So that means an identifier is something that does this process of identifying. So what would be an identifier? It's basically something that you create that is used to identify something. That's it. Simple. So what are examples of that? For example, variables. Variables, you can use they're also called another word for variables is identifier. Why identifier? Because variables are used to identify something. So num is this variable num, it identifies a number, or it helps me keep track of a number. So it's an identifier. So how do you name variables? What are the rules for naming variables? So these are the rules for naming variables that you need to know by heart, even if it means having to cram and sing them every day. Know the rules. So you cannot start with a digit. So when you coming up with the name for a variable or for an identifier, you don't start with the digit. It's gonna crash. Make sure you don't start with the digit. So by digit is any number from 0 to 9, including 0 and 9. You cannot start with the digit. And then what's another? The thing is, there's a lot of rules. Let me think of you cannot start with the digit. You cannot use reserved keywords. What is reserved keywords? Example, int. Example, bool. So basically anything that you write and it's highlighted in blue, anything that's part of C++, you cannot use that as the name of a variable. Because why is that the case? Because if imagine you did it, if you said int like this, C++ is going to ask you a question. It's going to be like, is this the name of the variable and then this is the type, of which that's going to be automatically incorrect because you're using the wrong order. Or is this the name of the variable and then this is the type and then this is the name, but then they're both types. So you mean type. What do you mean? So you see it gets confused. So that's why you don't use reserved keywords. We call them reserved. So reserved keywords is just any keywords that are part of the language. For example, for. The word for is reserved. It comes with C++. It's pre-installed into C++. You can't use that. And then variables can be of any length. So it doesn't matter how long your variables are. It can be of any length. And then for it's up to then the rest, it's like kind of flexible. And then you can also say your variables can include an underscore. You can include an underscore or a $sign. That's allowed. Those characters are allowed. If I remember very well, yeah, they are allowed. But then it's not advised. Even though you can include an underscore and it's legal, it's allowed, and you can include the $sign and it's legal, it's allowed. Make sure you don't start with an underscore and also don't start the variable with the $sign. Because if you put a $sign or you start with the underscore, what's going to happen is that the code C++ is going to get confused because sometimes when you install something that was written in C++, they created the variables using the $sign and the underscore. So it's gonna, let's say, for example, by coincidence, let's say you created a variable called int num, and then you said starting with underscore. So it's underscore int num. By coincidence, you installed maybe a compiler, and there's a variable called underscore int num. So you see that now the C++ is going to be confused. Do you mean the variable that comes with the compiler, or you mean your own variable that you just finished declaring? So that becomes very confusing. So make sure you do not start with an underscore, a $sign, even though it's allowed to include them in the name. So keep that in mind. So if I go back to the question paper, let me see. Yeah, you see there's the underscore. It's allowed. And you can have camel case. It's advisable, but it's not like a must. There's this thing called camel case. Let me explain camel case. So if you look at that's how, if you notice your lecturers, that's how they name their variables. So if you look at a camel's hump, right? So a camel's hump, they name this approach after camel's hump, because if you look at, you see a camel's hump, again it goes down like up like this and then down and then up. So this is what we call camel case. So let me show you why it's called camel case, because it mimics, or it looks similar to a camel's hump. So let's say I have a variable called int, right, num, and then I capitalize the first letter of the next word, num, or int number, right, of something, maybe oranges, I don't know, int number of something. If I look at this, I'm using camel case. Let me show you why it's called camel case. Look at when I put in a draw a line. There's the hump, and then there's the hump. So you see that it looks exactly similar to a camel's hump. So that's why it's called camel case, right? So it's a fun thing to think about. I want you to have that picture in your mind, that it's not a must for you to use camel case, but variables. Okay, I'm gonna say it is advised. So that means it's not a requirement. It's just advised to use camel case. So camel case is just advised to use. So if you look at your practical or your PDF, your question paper, they use camel case here. You see here, this is allowed, this is permitted. So if I copy this and I open Paint, can I mm, uh, okay, it's my first time doing this. Let me undo. And then, okay, they named it DB epsilon, right? And then if I zoom into this variable, right? Okay, just that this is not a good example, but it's still camel case. Why is it still? Yeah. So if I click here, you see that it still goes like this, and then there's the hump on the E, and then yeah, so it still kind of represents a camel's hump. So camel case, this is allowed. So this variable is fine. Underscore, remember we talked about the underscore, it is allowed, right? This is allowed. And then we'll skip this one for now. This is just A, it's allowed, even though, because if you remember your practicals, I'm sure some of you did, you can create a variable like this, int A, it's allowed because it follows all the rules. So you didn't start with the digit and use the letter, and it also didn't use a reserved word, and it can be of any length. Remember that bullet number 3, any length. I mean, even if it's like one character or one letter, that's also allowed. So that one is fine. Then we have dem3. The digit is at the end, so it's allowed. If it was at the beginning, then we're gonna have an issue. That would be illegal. So the only one that's illegal is this one over here, C. Why is it illegal? Because it is you might be like, yeah, but it shouldn't be legal. You see here, I'm using camel case. Yeah, you're using camel case. This part that I've highlighted is correct. The part that makes it incorrect is the hash. Because if you look at all the rules for naming a variable, we didn't say you can put a hash. We said you can only put an underscore, a dollar sign. So where's the hash coming from? So incorrect. So that's illegal. So the correct answer here, or the incorrect variable, is int val hash, which is C. So E, the answer is going to be C. And then we are done with that question, if I'm not mistaken. Let me see. Yeah, we're done with that question. Then I think we'll just go do question 3 now, fill in the missing word, and then we'll just end the session there. I don't want to keep you guys for too long. So let's do question 3. We're just going to be filling in what's missing, the missing words, right? So question 3, it's named in letters, right? Yeah. So A is going to be what? So let's check. So if you look at our code, right, we start by saying hash include IO stream, output stream, CSTD lib, C standard library, C math, right, library doing math operations or calling math functions. So using, and then here, what's missing here? It's namespace. So what's missing there is just namespace. So namespace in small letters, right? Not capital N. It's all small letters, namespace. And then what's missing in B? So if you look at B, they told you that this is a loop control variable for menu. That's not really important. What we need to understand is always look at the value. A char, to initialize a char, you put single quotes. To initialize a Boolean or bool type, you put in true or false. To initialize an integer, you put in a number without a dot. To initialize a double, you put in a number with the dot or with the decimal point. So those are the different examples. And then in a string, to initialize a string, you put in a value in between double quotes. So here I see that the only thing that's the data type that's applicable here is bool, because I see value true here. So B was going to be bool, the bool type or boolean. And then I'm gonna go back. And then it's gonna output options, question 3, option A, option B, exit. Simple, right? And then remember the null that I talked about. They even tell you, they explain, initialize to null character, because this represents a null character. And then here we need to capture the input. So what input are we capturing? Is the option that the user chooses, whether they're choosing A or they choose B or they choose X. Okay, these are the options there on this side. They choose the letter A or the letter B or the letter C. So that means the variable that I need to pass here, it needs to be of type char, because what the user enters is one character. And there's this is a variable of char type in the previous line. It's this one. So what for the answer for C is CH option, because I need to capture one character or one letter. In order to do that, you use the char type, a variable of the char type. Then I look at my switch statement. I see I have unsigned int. Unsigned means that it's a number that accepts only positive numbers. That's what unsigned means in C++. So don't be confused when you see unsigned. So cin reset the cin state. Yeah, that's why I always advise students to attend my sessions, because everything that I'm going to explain in the sessions is most likely going to be asked. You see this part here, I didn't talk about it in the videos when I was doing the memos for the practicals, because I knew students would see the videos being too long and not watch them, but not realizing that what I'm talking about will be asked in the semester test, and you're gonna get a big fat 0 for that question, because you didn't want to take the time to study. And this is also in your textbook. Everything that's being asked here, it's inside that textbook that you guys don't want to read. I know it's thick, but yeah, this is university. You have to study, you have to read. It's not high school anymore, whereby you're just freestyling. No, you can't freestyle at university. That's where you get 0 and they kick you out at UJ. So yeah, it's a serious offense to fail. So what's going on here? I need to reset the cin state. How do you reset the cin state? You call this function called clear. So what happens is that when you're entering something, let's say, let's look at this example. I'm outputting the string enter number of terms, and then I immediately get the number of terms from the user. But the user can enter an int. They're expected to enter an integer, but a user can enter a string. Maybe they enter hello world. So what happens is that C++ enters in what we call a fail state. So it enters what we call a fail state, meaning that getting input is stopped. No further input will be accepted. So it just fails. So the input, it just enters a fail state, meaning that you cannot get input anymore. In order to get input, you have to do two things. But in this case, in this example, they didn't do it, but you have to do two things. You have to reset the cin state, meaning return the return or basically remove the, okay, let me use the word clear. So basically you're gonna clear that failed state, that failed state it's in. That's step number one. How do you return? You clear the failed state, right? Meaning basically you remove that state it's in from failed state. After you've removed after you've cleared the failed state, right? Step one, you clear the failed state. Then after you've cleared step two, you're going to clean the buffer, right? Because there's this thing called a buffer. It's like a waiting area. So every time you type something, right? Let me show you an example. So if you type, let's say you want to get one number, but you actually typed 123 space 900 space 90,5 like this, and you wanted to get one number. What happens is that C++ takes all these numbers all at once as a big chunk and puts them in a waiting area called the buffer as they are. Then when it sees, so let me explain this. Let me cut this. So it puts it what we call a buffer, right? Which I want you to think of like a waiting area, like a queue. You know, when you're in a queue, whatever, you wait, right, to be helped. So it stores the values in what we call a buffer. Then it looks into your code line by line, looking for cin statements, basically statements where you're getting input. So let's say you want to get int. Let's say, okay, this is why you should attend. Those ones who are attending right now, you guys are learning a lot. I'm explaining a lot of stuff here. So let me say int a, and then no, let's say int b. I want to explain something also very important. So I have three variables, of all of them of type integer. In C++, if you have variables of the same type, you don't have to declare them separate. You can declare them all at once. So you put in the type first, then the variables, you list them one by one, separating each variable with the comma. So all of these will be integers or variables of data type int. So what happens is that this is the waiting area, right? This is the buffer. Then it sees the first cin statement. Let's say you want to store it inside num. Currently, num, so let me do this. Let me initialize all of them to 0 so that you see. So currently, all of these variables are 0, right? But when it gets to this line, you are telling C++ to go to the buffer, right? So let me show you, let me illustrate sort of like a mini demonstration. So you're telling C++ to go to the buffer, look for something that looks like an integer. So it's going to read character by character, right? Does this look like a number? Yes, it looks like a number. Does this look like a number? Yes, it looks like a number. Does this look like a number? Yes, it looks like a number. What about this space here? Well, that's not a number, so it stops, excluding that space. And then it cuts. It removes the thing out of the buffer. So now I'm only left with this. Remember CEN, right? It ignores all the spaces. Don't worry about the spaces. It skips them. Don't worry about them. So there's that number. Now it's being transferred. It's going to be transferred via what we call the standard input stream. I want you to think of the standard input stream as like a pipe. So imagine that number, you throw it inside the pipe. In that pipe that you're throwing it in, it has a label called standard input stream. So let me kind of demonstrate that. This is a very important topic to understand. You need to understand input thoroughly. If you understand input, you're not going to face any issues because you guys are actually going to do games. This semester, they're doing a game. So yeah, if you don't take C++ seriously, you're going to become an ancestor UJ. It's not even a joke, it's a fact. So I wish that was a joke, but yeah, it's not a joke, it's a fact. So tell your friends, those who are not attending, Nguri, so it's gonna go down. For now, this is easy. It looks hard. Trust me, this is easy. It looks hard, but this is easy. It gets worse. So this is the standard input stream, right? So imagine this is the standard input stream, right? And I have to explain everything because this is the theory question paper. They ask thoroughly. They need to make sure you understand C++. They won't be asking stupid questions like, what is the 1 + 1? No, they're not going to ask that. They need you to explain this. That's why I suggested you guys read the textbook because there's more information there. So you have the value here. Or let me just do this. Let's say that's the buffer. We have our buffer here. Right? So, okay, we have our buffer here. This is the buffer, right? So I'm going to put a label on top to say this is the buffer or the waiting area, if you want to view it in that way. That's the best example or analogy that I can make. So that's fine. Then I'm going to go back here, text. Then I'm going to put my text here. And then these are the numbers, right? Oh, I can do this. No, this is not what it won't help me achieve what I want to achieve. So I need to separate them. So 123, 900, and 90.5. 90.5. It doesn't matter whether they are stored in order, sequentially after one. It doesn't matter. Just know this is the waiting area for numbers. It's called, or for values or input that you type on the keyboard. It goes into a waiting area called the buffer. Then when it sees the first CIN statement, which is this one, it takes what matches or what looks like a number. So it's fine. I can put them in order so that you guys can kind of see how it does it. So there's a number here. So let me use different colors. This and then maybe green. So this is the buffer, right? So this is my buffer. These are the numbers, right? Imagine they were actually sequential. I think it's a bit easier to view them as sequential. So there's the number, right? So what happens is the buffer, when it sees the CIN statement, CIN, it refers to standard input stream, which is like a pipe for receiving information. So it takes that information, but another important thing that you also need to understand, everything in the buffer, the way it's stored, C++ thinks all of them are strings. So it's actually like this. I want you to also understand that part. It sees them like strings. So it's like the whole string like this. So it sees it like that. It's a string, even though it's a string that looks like a number. So that's enough information for C++. As long as it looks like a number, it can be converted to a number. Then what happens is it gets, when you see CIN, it means that take a number from the buffer, the number that's in the front, which is this one, 123, and then transfer it via this pipe. It goes via this pipe, but before it puts it in a variable, remember a variable is just a box. So I'm going to have a box here on this side. And then there's the box, right? There's my variable. So inside this is num, right? When you create a variable, I want you to think of a variable as like you're telling C++ to create a box, and then the variable name is the label on that box. So it's going to be labeled num. And there's two pieces of information that you need to understand. It also has the data type here. So data type, it's int, right? Meaning that's what it expects. It expects a number, an integer. That's very important to understand. So let's just make this blue and then make this brown. Something like this, right? So there's the box. There's the number. You see that it still looks like an int. It still is a string. But my box says that I can only accept things that are of the int type, meaning it's a number. But this is a string. So what happens is there's another process in between. So this is what happens. You guys might not see it, but there's a lot going on under the hood. So I'm gonna push this to the side so that I can demonstrate the thing properly. So there's the value, right? It's being passed from the buffer. So I'm gonna put an arrow to here to say that it's from the buffer to the input stream. But then it needs to be compatible. It needs to be of this type. So this is where a cast or casting takes place. It's invisible. You don't see it, but it does happen. So static underscore cast to an integer. What am I casting? This string 123, right? So there is here, and then I need to shift this to the side a bit, right? So there's the cast. And then make this blue. So after being, it's going to travel via the input stream. Then the input stream sends it to this guy to cast it, to convert it to the right type. Then from after it has been converted to the right type, it's going to be taken and stored into the box. So by the time it gets to the box, so there's the number. By the time it gets to the box, it's now an integer. So basically, that casting will simply remove the double quotes. And then by the time it gets into the box labeled num, it's now an integer. But then if something, do you know that do you know that there's something possible that can go wrong? If whatever's in between the string doesn't look like a number. For example, it's a string X. So let's say you entered in the keyboard, you entered X like this. So what happens is that it's going to store it in the buffer as usual, then transfer it or transport it via the input stream. Then it sends it to this guy to cast, to convert, and then it tries to store it in here, but then it's going to see that, let's say you entered X, it's going to see that, wait, I'm trying to put the character X into, this is a char or string or char, something of that nature. So to be honest, it won't even succeed because when you're trying to convert here, it's going to fail. So that process of failing, we call that a fail state. So it enters what we call a fail state. So it just stops. Everything stops. So you need to restore everything back to normal. How do you restore everything back to normal? We call that by clearing the fail state, meaning restoring it back to its normal state. Then once you're done, you can clean the buffer. But then the cleaning the buffer in this example, they didn't talk about it, right? So as I was saying, it's to the standard input stream, and then you cast, convert to an integer, then you store it inside num. So after this line has been executed, num now has the value 123. But then in the buffer, we still have these two other values that are left. Excuse me. So that's something very important to understand. So how do you restore? We're talking about to restore that. Once it's in a failed state, how do you restore it? You simply refer to your input stream. Remember, the problem went here when I was transferring from my input stream to my variable. So it tried to cast somewhere and then it failed. So I would have to restore my inputs, my standard input stream, because what enters the fail state is the standard input stream. And that standard input stream is referred to by which variable? Cin. So I have to call a function and say cin dot clear, right? Semicolon, which clears or restores my standard input stream from the fail state to its normal state. We call this clear, we just call the clear method. So that's what they were looking for there. So you have to say cin dot clear. So D is going to be cin. No, it's just going to be clear. You need to be careful of what's missing in the question paper. You see what's the only thing that's missing in the question paper? I have the dot here, I have cin, I have my semicolon. So the only thing that's missing is the function clear. So clear round brackets, that's the only thing that's missing. Don't put any extra things there. You need to be very careful. So here they said for every term. So remember, for every term, you start counting from 1, and then you keep on checking, have I reached my limit? So let's say I want to count to 30. I'm really gonna put one finger up and say 1, and then you're gonna check, is 1 equals to 30? Nope. Then you continue counting. You raise your next finger. 2 is 2, and then you ask the question, is 2 equal to 30? Nope. So I can continue counting. You raise the third finger. 3 is 3 equal to 30? Nope. So I can still continue counting. I raise the fourth finger, 4, and so forth, right? So to write that in C++, you'd say that, remember, if you look at when I'm counting, look at when you're counting. It's 1, 2, 3, 4. If we had to find the general term, this would just be +1, because this difference here is 1, the difference here is 1, the difference here is 1. So that means to move from 1 to 2, I added 1. To move from 2 to 3, it was 2 plus this 1, which gave me this 3. To move from 3 to 4, it was this 3 plus 1, which gave me 4. So in C++, to write that, you can write it in many ways. Let's say 3 ways. You can say the current variable I is equals to I plus 1, like this. Remember the assignment operator. It's called a right associative operator, because by right associative, it means it starts by running or doing something on the right. So you see, this is the operator. It starts doing something that's on the right of the equal sign before it handles the left side. So that means this might look not normal, but it's actually normal, because it's going to every statement or every variable that you put after the equal sign, you're telling C++ to do this. You're telling C++, listen, go look for this box to this label I, go inside the box, take what's inside the box and use it here. Whatever was inside that box, add 1 to it. So if I declared int I and then I started at 1 like this, so this will now be 2, because I said go inside what's inside my box, which is with the label I. What's inside the box? Currently there's 1. So put that value there. 1 plus 1 gives me 2. So I becomes 2. So I hope that makes sense. I try to make it simple as possible. So I hope that makes sense. So we now know how to increment or increase by 1. But since it's a common thing in C++, you can abbreviate it. You can say I plus equals 1, like this. Then there's a third way to also represent the same thing. You can say I plus plus. So there's 3 ways. There's first way is this one. And then second way is this one. And then third way is that one. We usually use, most of the time we use the third way or the third approach. So I'm going to use this, I plus plus. So for E, the answer is going to be I plus plus. So E, I plus plus. And then I'll share this diagram, guys. Don't worry about it. I'll share it in the group immediately after the session. And then we are almost done. Yeah, we're almost done. So let's look at this case. So we have something here. We're going through something. Excuse me. So we're going through something. So the way a for each loop works, right? You say you put the thing that is a collection of values on the right hand side, and then you move and then move into each of those things in that collection and grab one at a time. So a string data type, right? Under the hood, it uses what we call a char array. So it has a char array, meaning at every single position or every single index in the string, we have what we call a char. So that means here I'm going through basically what I'm doing, this for loop, what it's doing, it's going through every char. So since it's going through every char, that means that the only thing that's missing here is char, because C has to be of char type, because every small letter here, or every letter in this one string, is of type char. I would demonstrate later on when we have a bit of time. I could explain this, but then that will add an extra 30 minutes of explanation. So we'll do it maybe in the next question paper. I'll explain it thoroughly. For now, I just want you guys not to be bored and end up being tired and saying, hey, when is this guy finishing? So let me tell you the answer there. Yes, it's supposed to be char. So that's char. And then test to see if the character is a comma, right? And then output if it's not a comma. So sometimes reading these comments, you see these comments, they help guide you. They said we should output that character as long as it's not a comma. So how do we output something that's not a comma? We can just say it's not equals to that thing that we're looking for, because we're not looking for that thing. They said not a comma. So not a comma, it means if it was a comma, so this is where you have to use critical thinking. If you remember in logic, right? Or yeah, if you remember logic and relational operators, so we have equals, two equal sign. It just means it just means the thing on the left hand side, does it have the same value as the thing on the right hand side? That's what that means. So if we wanted to look for a comma, we'd say C, right, is equals to or the C is equals to comma. If we were looking for a comma, that means that character we're looking for is a comma, then we'd output a comma. But we are looking for not a comma. So how do we negate this? This is equals. How do we negate that? So not equals is just not equals, right? So how do you write not equals in C++? It's exclamation mark and an equal sign. This means not equals. So this means not equals, because we are not looking for a comma. So I'm going to use not equals. So if you check this, they said output everything if it's not a comma, meaning it's not equals to a comma, then output it. So G, what's missing there, it's not equals. So I'm going to go back here. So what's missing is not equals. And then we're going to scroll down. We're left with H. Oh, there's still more. But yeah, we're almost done. Hij. So at H, this handles any other cases without exiting, right? Any other cases. By any other cases means any other case, right? If you still remember the tutorial that we had when we were talking about selections, right? If statements, switches, whatever. I told you that the word that you can use there is default, which is the same as like else in an if statement. So the keyword that's missing there is default. So you just need to write default there. Small letters, it's all small letters. There's no capital letter. And then it's the loop to continue if the user did not, or okay, continue loop if the user did not end it. How do you end the loop? Basically, you have to understand how the loop can end. How do you end the loop? So if you scroll up, That's why sometimes you need to read your code and understand. You have to go back up at the top and understand which options are available. You see that if you enter the letter A, you are doing option A. If you enter the letter B, you're doing option B. If you enter the letter X, you're exiting. So that means to exit, use the character X. But then here, if you check here, they said, let me check something. Yeah. So the variable that stores the inputs or the options that the users entered, it's CH option. So you need to copy that. You're going to use that variable down there. And then here, if you check the comment, it says that this loop should continue if the user did not end it, meaning as long as the user has not entered X. How do we check if the user has not entered X? It's basically as long as CH option is not equals to the character X. It means that the user doesn't want to exit yet. So that's what they expected you to write there. So I'm going to say CH option, as long as that's not equals to the character X, then I know my user still wants to continue. But the moment when they press X or they enter X, then, oh, it means they want to exit, then the loop should just stop on its own automatically. So I hope that makes sense. And then exit program with success code. To exit a program in C++, you need to return 0. If you still remember the main function, it is return 0. Here they left the 0. So the only thing that's missing is the return keyword. So I'm going to say return and then boom. So you should get totals in question 2 and 3 for this paper. So those were the answers. And then I think I should end it here because time is not on our side. And the brain has been proven that it can focus from like between 30 minutes to like maybe 45 minutes, somewhere there. So now I'm sure you guys are definitely not focusing now. So brain's tired. So it's fine. We'll continue. I don't know when, because tomorrow you guys have a practice session. So maybe Saturday. So yeah, we'll continue question 4. Then question 5. After question 5, we're gonna go back to question 1 to do those calculations over here. So I hope everything made sense. So that's it for today's tutorial. See you in the next session. So I'll just stop recording now and then take questions if anyone has a question.